Okay, let's look at trying to discover the second part of the fundamental theorem of calculus. So here we've got integral from 0 to x squared of f prime of t dt. So same thing as last time. Step 1, find the antiderivative. Step 2, plug in the limits. So let's do step 1. Find the antiderivative. Now this is a derivative. So the antiderivative of this derivative is going to be the original function with our limits from 0 to x squared. Step 2, let's plug in our limits. So I'm going to get, here we'll do my brackets for a little longer to help you see this. So my upper limit, plug in my upper limit, it's going to be f of x squared, minus, plug in my lower limit, it's going to be f of 0. So I'm going to get f of x squared minus f of 0. Okay. Number 4, I want to take the derivative of number 3. So this part right there, that is exactly the same as number 3. So that is f of x squared minus f of 0. So I want to take the derivative of f of x squared minus f of 0. Now, I'm going to be a little careful doing this one. Let's go one by one. So first off, the derivative of f of x squared. Well, the derivative of f is going to be f prime of x squared. Now, here's the careful part. This is a chain rule derivative. I took the derivative of the outside. Now I need to multiply by the derivative of the inside. This is a chain rule. So the derivative of the inside is going to be 2x. Minus, that one's still a number, just f of 0. So derivative of a number is just going to be 0. So then I get f prime of x squared times 2x. Okay, let's try example 5 and 6. I want you to try number 5 on your own. Following those same 2 steps, take the antiderivative and then plug in the limits. And then come back and check your answer to see how you did. Okay, check what you got with what I got. I got f of 2x minus f of x cubed, because the derivative, or the antiderivative of the derivative is the original, and then I just plug in the limits and subtract. Now let's do number 6 together. Remember that this is number 5, so let's plug in what we got from number 5 for that. So I'm going to take the derivative of f of 2x minus f of x cubed. Let's do this one at a time again. So the derivative of f is going to be f prime of 2x. And then once again, this is a chain rule. So times by the derivative of the inside times by 2 minus the derivative of f is going to be f prime of x cubed times by chain rule derivative of the inside 3x squared. Now, let's talk about this. Can you see that what we're doing, so let's take a second to compare this with my final answer, this. Notice first off, the equation inside hasn't changed. We went from f prime to f prime. The only thing that's happened is I've plugged in my limits, 2x and x cubed, subtracted them, and then these right here are the big difference. I always end up multiplying by the derivative of my limits. So my limit's 2x, I multiply by the derivative of the limit. Limit's x cubed, multiply by the derivative of the limit. This is the second fundamental theorem of calculus. Right here, you're going to want to box, highlight, square, star, circle, all of the above, this. If I take the derivative of a definite integral, where these are numbers or letter or variables or equations of some equation, some function, I'm going to get the upper limit plugged into the function times by the derivative of this upper limit minus the lower limit plugged into the function times by the derivative of the lower limit. That is what the second fundamental theorem of calculus says. In the next video, we'll go through a couple examples where we apply this theorem.